Welcome to a build video. This is for the LCD rucksack, and it's a through-hole assembly. Should take you about an hour, and it gives you some great capabilities. I'll take you through this as an overview, and then we'll look at how to build it. So what is the LCD rucksack? It's a very simple backpack or LCD edition that allows you to connect to lots of different commercially available LCDs that provides you a serial I2C, SPI, or optionally Wi-Fi interface using a little microcontroller on board on that backpack. We provide it as a fully built kit, as a bag of parts, just the PCB. You can then source your own components, or just a hex if you want to do it from the ground up. But essentially, it's a backpack, and I'll show that backpack working. Here it is here. Um, it's currently connected in serially through this wire here. I've got voltage coming through this wire here, and you can see that it's incrementing up the time, and there's a nice display on here. Now what is interesting is that you have control over the fonts here, positions, the X and Y positions of your text. You have inputs and outputs on the back. I'm not going to go in too much into the details of the capabilities of the LCD rucksack, but it's a very good product that enables you to integrate your projects, and it gives you very nice control. What does it look like? It looks like one of these. It's got a 16 by one-way connector, series of headers that allows you to control it. But IC goes in the top, and you can control the contrast here with a nice reset button, of course. Now, I'm not going to go any further into what it does apart from what I'm going to show you in the video. Let's get cracking on the build. So this is the actual PCB itself we're going to be using. As I said, it has headers, number of passive components, and other simple components that you can source. The bill of materials we provide, as I said, very simple, very few components. But what's nice is you get a bag of parts that you can put together very quickly. I create these pick sheets. I then place my components on the pick sheet, and as I do my build, I can then rapidly and quickly assemble my PCB. There's two pick sheets. One is for the bottom, and the other is for the top. Now, the build process is quite important. You must follow this process, else you'll end up with isolated parts, which means you can't assemble it. So it is a very small board, and that board needs to be assembled following this process. So, number one, fit the oscillator on the bottom, and don't fit any headers or connectors. Fit the capacitors on the bottom. There's three of those. One either side of the oscillator, then an additional one. Fit the bottom resistor. There is one resistor there that is a different value in the to the three, so I've marked them as a single one, and then there's the triple. Flip the board over and work from the top left-hand side clockwise, fitting the components as you go through. Be careful where you put the Zener diodes. It's clearly annotated as a Zener diode, and fit that in the correct place on the board, which is also mud. And as you can see from this diagram, the board is fully annotated, so you can find your components where they need to go and the values very easily. Then fit the vertical headers. There's 5 of those to be fitted on the top. Flip it over and then fit the vertical headers for the LCD itself. Now you can choose a 16-way male or female header, or you can do the same as an 8x2 header as well. Choose what is ever required for your specific LCD needs. Then fit the 3 angle headers on the bottom. Flip it over again, and then fit the optional socket for the IC, the potentiometer, and then push the chip into the socket, or solder that chip directly onto the PCB. You can reprogram. You can provide you updated hex, and you can program that via the SPI. So if you decide to solder the IC directly onto the board, it's not a constraint. So that process took me 50 minutes end to end. That's 40 minutes of soldering, and then 50 minutes with the test I'm just going to show you now. So the build, it looks like this is my build. There's two seconds per photograph. This is when I was building it. As you can see, I selected a 16:1 female, and then I put my socket in the top and then push my chip in. Okay. So let's just complete that build, and we need to test it. So fit your chip, provide some voltage, and then there is a test and ground, so that we can actually test and ground to test the thing. So connect up a little jumper here. Let me just mark that quite clearly. Here is a test jumper, put 0 and 5 volts on it, and you'll see it runs an internal test. So what we're going to do, we're going to do that live, okay? So you saw the device working earlier on. I'm just going to slide in here, and I'm just going to disconnect the serial, and now it's stopped updating that, just to prove to you. And there is a jumper on the back that I've been using, so I'm just going to connect that jumper into the test and ground, and I'll press that reset button on the back. That reset is the same as connecting the 0 and ground, and you can now see that is running a test program. And that test program is useful to ensure that the IC is operating and that your contrast is acceptable before you proceed to actually using it. Now I am wearing a strap here so that you know. So I'm going to reconnect my serial connection. I'm just going to pop that on my serial connector, and then here is my serial signal. And I'm just going to very quickly push that into here. There we go, great. Now I'm just going to press the reset button on that, and I'm just going to go over to my computer, and I'm going to update it. Now let me just go to my computer, and I'm going to show you a tiny little script that I've written for the purposes of demonstration. So discard my PowerPoint, go to my desktop, and here's my desktop. I've got a very simple script here, and this script is essentially sending the time and date, time and text, to the COM port, and the COM port is a standard serial port, so I'm using the serial interface. And here's the batch file running. If I just stop that for one moment, restart it, we look at the lab again, and we can see that 50 seconds has passed since I last looked, and that's now running. So if I want to change that batch file, just to show how simple it is to use this, I'll say hello in here. I'm just going to type that text in there and change that, and restart my batch file. There we go. Just restart the batch file and look at the lab, and we should see that we have a successful hello on the LCD. So that's pretty good. Let's go back into PowerPoint just to summarize up where we are. So once you've assembled it and you've tested it, you can then test your serial. You can use as I said, that's a simple test. Then you can select the I2C or SPI and Wi-Fi. And on the back of the PCB, you'll see how to use the communication select headers. That's extremely simple, but that's the purpose of another video. This is all about building it. So that was a very fast introduction and overview of how to build the rucksack. Go and enjoy.